Hi, Evergreen. We are going to learn about Chapter 6, Lesson 1 and 2 today because they are so easy. We are going to squish them together. Line symmetry and proving lines parallel. Let's get started. Get your book and your paper and your pencil and let's dig in. Okay, definitions. 2 points are symmetrical with respect to a line if and only if the line is the perpendicular bisector of the line segment connecting 2 points. So they are giving you some definitions of perpendicular bisectors. So remember how we used to have a line segment and we learned how to bisect that angle with a midpoint, and then AB is equal on both sides of this middle point. Okay? And they are perpendicular with a 90-degree angle. Next, Theorem 16. In a plane, 2 points, each equidistant from the endpoints of a line segment, determine the perpendicular bisector of a line segment. So, PQ is our line segment. And imagine we used our compass to bisect this line. We drew an arc this direction and that direction, and then we did the same thing below, this and that. We connected these dots or these points of intersection, and then we created a little rhombus or parallelogram. Okay? And what they're wanting you to see is that all these connecting sides are equal because PJ and JQ are equal, and JA and JB are an equal distance apart. So if you're working with a top line segment and bottom line segment that are equal in distance, and a left and right line segment that are equal in distance, therefore your sides that are diagonal connecting your points will also be equal, and you will have a perpendicular angle in the center. Lines of symmetry and triangles. Some of the questions in this lesson are going to have you copy a figure down and then draw a line of symmetry. So the first one is an isosceles triangle. An isosceles has 2 sides that are the same, and therefore it will go down the middle of the top angle where the left and right sides are the same. An equilateral triangle has 3 lines of symmetry, one going from every point down to the center of the side. So it goes from this top point of the triangle down through the middle of this bottom side. And then we'll go over here to this right corner of the angle of the triangle, and it goes straight through the bottom or the left side. And you can imagine this going from the last corner as well. So since an equilateral triangle has 3 equal angles and 3 equal sides, it has 3 lines of symmetry. You want to be able to imagine folding it in half and it touching exactly, matching exactly. Now a scalene, since it has 0 lines that are the same length, it also has 0 lines of symmetry. And then a square, of course, can be having 4 lines of symmetry. It has 1 from each corner, so 1 going diagonally this direction, 1 diagonally this direction, 1 from top to bottom in the center vertically, and 1 horizontally. A rectangle has 2 going vertical and horizontal. The reason it cannot go diagonally, even though these triangles would be congruent, this wouldn't be a line of symmetry, because if we folded this in half, it would not overlap exactly. A rhombus is just like a square, except it doesn't have a 90-degree angle in this rhombus, and so therefore it only has it going from the corners instead of the sides. Okay, we're going to go and do, that's preparing you for numbers 5, 6, 7, 8, 9, and 10 on lesson 6-1. If you want to pause the video, go ahead and draw your lines through your shapes of symmetry, or your lines of symmetry through your shapes. You can do that, or you can keep going and then do that later. Number 21 through 27 are all going to be proofs using the information that you know. So in your book, it says stealth bomber. in this view of a B-2 stealth bomber, points S and T are symmetric with respect to line L. So since they're symmetric, that we know that SM is equal to MT, okay? And since they are perpendicular, we can know that these are perpendicular since they are equal in distance. So what can you conclude about line L? Give a reason for each of the following. So what can we guess about this red line L? Well, we know that line L is perpendicular. It is the perpendicular bisector of ST. And this goes with our theorem 16. Number 22, SM is equal to line segment MT. We know this because it is divided into two equal segments. If a line segment is bisected, it is divided into two equal segments. Bi, meaning two, and then here, two equal segments. Oops. 23. Angle BMS and BMT are right angles. So let's look at this. BMS, BMT, they're right angles because these are perpendicular lines intersecting. So 23 is perpendicular lines always form right angles. This goes with theorem 16 as well. 24. Angle BMS, so BMS is equal to BMT, BMT. So how are these two angles equal? Well, they're both perpendicular. They both form right angles, and so therefore, all right angles are equal. They all are 90 degrees. 25. MB equals MB. Now, anytime you see the same thing on the left and the right of an equal sign, and it is exactly the same, like a reflection, it is the reflexive theorem. 26, triangle BMS, so BMS, we're going to use this side of the bomber, and triangle BMT, BMT, are congruent. And how do we know they're congruent? Well, we know they share BM as one side. We also know from number 22 that SM and MT are the same distance, and we just talked about how this angle is the same as well. So side, angle, side. We know they're congruent because of the side, angle, side. And 27, BS, this diagonal, is equal to BT. Well, congruent triangles also have congruent all parts of the triangles are congruent. So this side is congruent, and these MT and SM are congruent. This angle is congruent, and therefore we know that this diagonal, the hypotenuse of each of these triangles, is also congruent. So the way you say this in a proof is corresponding parts of congruent triangles are equal. Okay, let's go through some definitions from 6.2 now. So we are on page 219 if you want to follow along in the book. So two lines are parallel if and only if they lie on the same plane and do not intersect. We already know this basically from maybe first grade, but just in case. Now this might be something new though. A third intersecting line called a transversal is a line that goes across parallel lines. So this diagonal line intersecting both parallel lines is called a transversal. Whenever a transversal intersects parallel lines, it forms corresponding angles. Corresponding angles are always congruent. That means equal to each other. So it's kind of like, symmetry, a parallel image. So here we have parallel lines 1 and 2, and the transversal is going diagonally across both of them, and it's a mirror image. It's like the same thing separated. So 1 and 5 are equal, 4 and 8 are equal, 3 and 7 are equal, 6 and 2 are equal. So the same angle on the same section of the parallel line using the transversal line as a reference point are always congruent. That's a really cool thing. Next, we have alternate interior angles. So here are parallel lines K and M. The angles that are formed inside of the parallel lines with the transversal are called interior angles. Okay, so anything in between the parallel lines are interior angles. Alternate basically means the diagonal angle. So 3 and 6 are congruent, 4 and 5 are congruent. Also, same side interior angles. So we know that these are interior angles, right? Because they are in between the parallel lines. Guess what? They have a really cool thing. They always add to 180. And angles that add to 180 are called supplementary angles. So 3 and 6 will add to 180. And so guess what? Do 4 and 5 add to 180? Yes. So these are same side interior angles. I like the names of these because they really tell you exactly what it means. Same side of the transversal and interior angles. They are inside the parallel lines. So here is a chart kind of showing all of the angles and their relationships. So let's start here on this red section, alternate exterior angles. So let's find our parallel lines. We see our transversal, and do you see alternate? That means kind of like opposite, exterior. So if these were interior inside of the parallel lines, guess what the angles outside of the parallel lines are called? Exterior. So exterior, interior, exterior. There are 4 interior angles, 1, 2, 3, 4, and there are 4 exterior angles, 1, 2 on the top of the transversal, and 3, 4 on the bottom of this transversal line with the bottom parallel line. So angles that are on opposite sides of the transversal, so here's the transversal, opposite, opposite, are alternate. And guess what? They're congruent. Now let's go to the alternate interior angles. So here's our parallel lines, 1, 2, our transversal, and these are interior angles because they are inside of the parallel lines. Alternate because they are on opposite sides of the transversal. And guess what? They are congruent as well. And then corresponding angles, we talked about this also already, but angles that are having the same position in the geometric figures. So we have parallel lines going across. We have our transversal. These are on the same relationship between transversal and the parallel line. It's in this top left section. So top left section. So these are, they are congruent. So then this bottom and this bottom section are congruent. This section and this section are congruent. And this top right with the transversal and the parallel line and the top right of the transversal and the parallel line are also congruent. Good job. Now, same side interior angles. We already talked about this, but just to be sure, these are our internal angles and they're on the same side, so therefore they are supplementary. They're going to add to 180 degrees. And then the same side exterior angles. We have exterior angles on the top and the bottom of the parallel lines, and they're on the same side. So guess what they add to? They're supplementary as well. Okay, so this transversal line helps us know the degree of angles in parallel lines. It helps us to also just see the relationships of how this creates symmetry. So theorem 17, equal corresponding angles means that the lines are parallel. So anytime that you see these relationships happening, this is a way to prove that lines are parallel. Corollary 1. Equal alternating interior angles mean that lines are parallel. So all those things we just talked about are ways to prove lines are parallel. That is the point of this chapter. Proving lines are parallel using rules that you know. Corollary 2. Supplementary interior angles on the same side of the transversal mean that the lines are parallel. So this is a way to prove lines are parallel. If angle 4 plus angle 5 add to 180 degrees, you know that line A and B are parallel. And these two lines right here means parallel. Corollary 3. In a plane, two lines perpendicular to a third line are parallel. So if you ever have perpendicular lines, you know that they are having a 90-degree angle. And if you have two sets, then you know that they have parallel lines if they're two 90-degree angles with the transversal. Okay, so let's just talk about it one more time. So here's our term. A transversal is this line right here, woo, that goes through a set of parallel lines. It gives us relationships. These angles inside of the parallel lines are interior angles. The lines outside, above, and below are called exterior angles. Corresponding angles are lying in the same spot. So it says 1 and 5 are corresponding. Do you see how they're in the same relationship between the transversal line and the parallel line? Top left section, bottom left section. Right bottom section, top right section. So these are showing relationships because they are corresponding angles. Alternate interior angles, so we have interior angles. Alternate means opposite, so 3 and 6 are alternate, 4 and 5 are alternate. Alternate exterior angles, so we're dealing with our exterior angles. Opposite spots are 1 and 8 and 2 and 7. Same side interior angles, same side interior, so 4 and 6 are same side interior and they add to 180. 3 and 5 are on the same side and they're interior and they add to 180. Okay, last three questions on page 221. So corollary 1, remember what corollary 1 was. It says equal alternate interior angles mean that lines are parallel. So it gives us that angle 1 equals angle 2. Angle 1 equals angle 2. Are these interior angles? Yes. Are they alternate? Yes. Okay. We need to prove that A is parallel to B. So number 1, what is given to us? Well, angle 1 equals angle 2. That is what's given to us. 2, vertical angles are equal. Vertical angles, ooh, that's 2 and 3, right? These are our vertical angles. So angle 2 equals angle 3. And then what could we substitute for angle 3? Ooh, I know. Angle 1 is equal to angle 3. We substituted 1 for angle 2. And so equal corresponding angles mean that lines are parallel. So therefore we can give our proof as our number 4. We have proved that line A is parallel to line B. Let's do it again with corollary number 2. So corollary number 2, supplementary interior angles on the same side of a transversal mean that lines are parallel. So this is our given. Angle 1 and angle 2 are supplementary. So that means they add to 180 degrees. We have a job. Prove that line A is parallel to line B. So we need to list what is given. What is given is angle 1 and angle 2 are supplementary. If we were going to use the angles in a linear pair that are supplementary, what else is supplementary besides 1 and 2? 2 and 3. So we'd say 2 and 3 are supplementary. And then for number 3, supplements of the same angle are equal. So if they are equal supplements, we know that 1 is equal to 3 because 1 and 2 were supplementary. And 2 and 3 are supplementary. Since 2 is in both of these statements, we know that angle 1 must equal angle 3. And therefore, our final proof is equal corresponding angles mean that lines are parallel. Line A is parallel to line B. Last one. Corollary 3. In a plane, two lines perpendicular to a third line are called parallel. So this is what is given. line A is perpendicular to C, and line B is perpendicular to C. So we have two lines, A and B. We need to prove that they are parallel, but we are given that line C, our transversal, makes perpendicular angles right here. So what are we given? We are given this. We would rewrite this statement right here. A is perpendicular to C and B is perpendicular to C. Next, perpendicular lines form right angles. How do we know this? What is our statement that we can do? Angle 1 and angle 2 are right angles. All right angles are equal. Yes, so we're going to write the two angles that are equal. Angle 1 is equal to angle 2. Then, have we proven what we wanted to? Yes, equal corresponding angles mean that lines are parallel. They're corresponding because they are in the same place in reference to the transversal and the parallel lines. They are in the top right section, each of them. So they are corresponding and they are equal, so they are parallel. So 4, we'd write A is parallel to B. Okay, guys, we did it. Y'all did so great. I hope you have an awesome day, and I will see you tomorrow. Bye.